Welcome back to a new video. In this video we are going to talk about time series forecasting using the ARIMA model in Python. We are going to talk about its parameters and how we can do forecasts using the ARIMA models. Let's start by importing libraries that we are going to use. I'm going to import pandas and I'm going to import NumPy. I'm going to import matplotlib.pyplot as PLT, and we are going to import the ARIMA from, actually let me quickly fix this. So I'm going to say from stats models, time series analysis, ARIMA model, import ARIMA, like this. Here are the libraries that we are going to use, and we are going to create a data set for this modeling. We will say date range is going to be equal to the pandas date range. We will say start is going to be like, actually I need to use lowercase, or I will say 2023-01-01, and end is going to be equal to the 2023-12-31. Great, so I will say frequency as the last parameter, and I'm going to set this daily. So if I call this, you will see that we will get the daily data for the 2023. Great. So I'm going to create something like time series data, and I will say pd series numpy.random number, and I will say length of the date range, and I will say index is going to be date range. So we are creating a completely random data, and I will just call it, like you can see that we have the series in here and we have random data. Since we have a completely random data, the model can be just like not looking good, but you need to apply this to your own data sets. I'm just creating this data to show you how you can implement these ARIMA models in your data. So if I just rerun this, our data will change because it's random. And I'm just going to plot this for getting a good one, like I will say plt.plot, and I'm going to say time series data. Let's give the title like ARIMA data, and I will use plt.show. And after that we can see our data. Great, I can just rerun this and you will see that our shape is going to change in here like this, and we can do it as much times that we want, like this. Okay, let's work with this one. I'm going to create a model, like model is going to be ARIMA time series data, and we can set order like 1 1 1. And let's talk about these orders. The first value, this one is P, second one is D, and third is Q. So we are going to talk about that. It's something like P, D, and Q. And now we are going to start by talking about the P autoregressive part. And this represents the number of log observations included in the model. It signifies the number of previous time points used to predict the current point in the time series. A higher value of P implies a more complex autoregressive component. So we will just check the lags on this. So let's talk about the D. It is integrated component, integrated. So this is the order of differencing needed to make the series stationary. If the original time series is not stationary, differencing is applied to remove trends or seasonality. The value of D indicates how many times differencing was performed. And let's talk about our last component, Q. It's moving average. This refers to the size of the moving average window, representing the number of lagged forecast errors in the prediction equation. It helps capture the effect of past forecast errors on the current observation. A higher Q value implies a more complex moving average component. For example, let's say 2, 1, and 3. So P is 2 in here, we are using the 2 previous time points for autoregression. D is 1 here, we perform differencing once to make the time series stationary. Q is 3 in here, we consider 3 lagged forecast errors for the moving average component. Choosing the appropriate values for P, D, and Q is crucial for the ARIMA model's effectiveness. It's a simple implementation, so I'm just going to take 1, 1, 1 in here like this, and we are going to work on this model. And I'm just going to train this model like I will say fit model is going to be model.fit, and here it is. After that, I will say forecast steps. It's a number of days you want to forecast. Since our data is daily, I will say 30 for now. We are going to change that later on. And I will set forecast like fit model. We have the forecast method in ARIMA class, and I will say steps is going to be forecast steps. After that, let's just visualize our predictions like I will say plt.plot, and I will give time series data. Its label is going to be original data, and let's also plot forecast with the label forecast, and we will say plt.legend, of course, for seeing the legends. I will say plt.title ARIMA forecasts, and I will use plt.show, and here it is. So here are our forecasts. Since data is changing too much, it just gave a straight line because it can predict this change, and you can just extend this forecast like you can just say 90 in here and you'll get the forecast of the 3 months, and you can just say 180 and you will get the forecast of 6 months. It's all straight line because this data is random. You can just change the order of the model, like you can say 2, 3 and 2, and let's just try it out and see how it will work. We can see that the line is much different right now. You need to find the appropriate good values, like let's say 3 in here, 1 in here, 2 in here, and let's retrain our model. I'm just going to plot this again, and it's a straight line again. You can change this as many times as you want, but there's ways to find the optimal values. We are not going to talk about them in this small lecture. So as I said, if your data is not random, you will get better forecasts. And that was all for this lecture. Thanks for watching this video, and I'm creating content about data science and programming. If you are interested in these topics, you can subscribe to my channel for more videos like this. Have a great day.